be getting in, but I think we can get started. So who here already knows a little bit about Pygame versus like who's like completely new to it? So who feels like they already know Pygame relatively well? Eddie, Chloe, Jimmy, all the kind of half and half. All right, cool. So yeah, so does everyone have it installed on their computer already? Elena?
Hey.
Because if not, you can like I said in the Discord, you can do it on REPL or Trinket, I think. And like, a site like that, but it just, runs smoother if it's actually on your computer. So yeah, I guess we can go ahead and get started. I'm going to go ahead. You can go ahead and open up the text editor of your choice. I'm going to be using Visual Studio Code, but it does not matter at all. So we go ahead and share that. And yeah, I'm just going to go ahead and create a Python file. So I'm going to make a new file, save it, and you can call it whatever you want. I'm going to call it platformer.py because that's what we're going to make. We're going to make a platformer. Unless there's any specific request, if anyone wants me to make a last minute pivot, like, no, I really, really wanted to make like a Galaga type game, then we can do that. But seems like everyone was on board with the platformer. So let's go ahead and get started. So Pygame is a library for exactly what it sounds like, making games in Python. So it's a great tool if you are working with a student that wants to make games and is getting kind of sick of the command line apps that you might be making otherwise, and doesn't really want to do anything else besides like games. So one option for kind of a visual aspect of Python is Python Turtle, which is fantastic, but doesn't really let you make games in the same sense that Pygame does. And then there's also processing as an option, which is also a fantastic library, and that's more, I would say that's more for like animations or art sort of projects. Although you can definitely make games in it, I think Pygame makes it a little easier, whereas processing is a little better if it's not as much of a game. So for this, in order to make a Pygame app, you're going to have some boilerplate code that's going to apply to pretty much every game. You need to load up a screen and have things happen on that screen. And how you do that can really be up to your style. Some people like to make like a game or an app class and keep everything inside that class to avoid using a bunch of global variables and stuff. But I'm not going to do that. I'm just going to have simple just setup and then game loop. So at the start, I'm going to import Pygame, and then I'm going to say pygame.init. So the init function, to be honest, I don't remember everything it does off the top of my head, but you just want to run it at the beginning of all your Pygame games, all your Pygame apps. It does stuff like initialize the different modules that need to be initialized and like the time in the game and just a bunch of stuff. So all you need to know is just run it at the beginning before any Pygame stuff actually happens in your file. And then we're going to need to make the screen appear. So I'm just going to go ahead and tell it how big to make the screen. I'm going to say width and height equal, and you can put whatever numbers you want here. I'm just going to have it be 500 by 500. Just how many pixels wide and tall is the screen going to be? And then I got to make the screen. So I'm going to make a variable for it and say pygame.display.set_mode. And then you got to put a tuple in here. You don't put just one. It's not two arguments. You got to put them together as one argument, but then you put in the width and the height. So is everyone following along so far? Anyone need that code explained? Yeah, we got to write a little bit of code before we can actually test anything. But any questions? Cool. So then let's go ahead and keep going. So this I like to mark if I'm working with a student as like the setup step to kind of let them know that everything here, like there's going to be more that we add to it. Even though we're going to move on pretty soon into the actual like playing the game step, there is still going to be more things that need to happen at the beginning, and we may not necessarily be doing our code chronologically with what makes sense to us as we approach it. So I just kind of mark this as the setup step. So anything that needs to happen in setup goes here. And then we're going to go ahead and start the actual main game loop, where anything that happens during the game is going to occur. So I'm going to make a variable called playing and set it to true, which just says, am I still playing the game? So that when I want to leave, I can set it to false. So while playing, this is where the actual game code goes. And we'll get to this in a second, but basically every iteration of this loop is going to be one frame of the game. So everything we do is going to happen once per frame. And one of those things, the first thing we're going to want to do is going to have a way to exit. We need to make sure that if they want to leave the game, they're not just stuck in there perpetually, or that you have to close it externally by killing the process from outside the game. So it's just like, okay, we need it to be when they press the X button, it actually ends. So I'm going to say for event in pygame.event.get. So all I'm doing here is looking through everything that the player did since the last frame. That's what pygame.event.get does. It just returns a list of everything that the player did since the last frame. So that could be moving their mouse. It could be pressing a key. It could be, in this case, pressing the X button is what we're going to want to look for. So we say if that event.type equals pygame.quit. Then we're just going to say playing equals false, which will end the loop the next time it loops around, and thus end the Pygame program. And then there's one last thing we'll have to do, which is to make it actually update each frame. And that's Pygame dot, well, I'm totally drawing a blank here. I literally just wrote this. Pygame dot display dot, does anyone remember? Why am I drawing a blank on this? I can just cheat here and look at my other, yeah, update. Pygame dot display dot update. All right. So now we have that. I'm going to go ahead and test this out. And hopefully I didn't miss anything. Yeah, so it just brings up a black screen, 500 by 500. Nothing's happening on it. I didn't tell it to do anything. But if I press the X button, it disappears. So this code here is pretty much going to be in every game you ever write, if this is the style you choose. Like, again, you could choose to make it into an app, like class, and keep everything in there. You could choose to, just put this inside a while true and have this be a break. Like little things, little stylistic differences that you can make. But the core concepts are going to be in every single game. You got to initialize it, create the screen, and then have a way to actually play the game. And all your code is basically going to go into here. Does anybody have any questions on that so far? So yeah, I would even have this like saved, or have something similar with whatever additions you want saved, so that you can just quickly, anytime you want to start a new game, just open up that file, make a copy of it, and then go. Or if you don't want your students to have to bother with the boilerplate code, I find it valuable to have them write this at least the first few times so that they know what's going on. But you can just like send it to them and they don't have to bother with it. So like I said, I want to make a platformer. So what am I going to have to do to make a platform? What steps am I going to have to take? What's the first thing I'm going to need when making?
You need a sprite.
You need a sprite. Yeah, you need some sort of player that can show up on the screen. So I'm going to go ahead and make a player class for the player. So I'm going to go ahead and say class player. And since it's a Python class, I'm going to have to define the initialization function. And inside this initialization function, since there's only going to be one player, it's up to you whether you make these arguments or whether you just set them inside the player itself. but I like making them arguments. So it's going to need an X, a Y, a width, and a height for the actual sprite, and a color as well, so we can display it. And then you can just, save all these. All right, does anyone have any questions about the player so far? Or anything we've done? So these are the things it's going to need to keep track of. You could also just have, one size variable if you wanted to always be a square, which mine is going to be. I'm just going to set the width and the height the same, but I like having that flexibility to do something different with it. Yeah. So after that, what does the player actually need to do?
Move.
Yeah, it's got to move around, right? Yeah, and even before that, it's going to need to be able to display itself on the screen as well. So it'll need to we need a way to actually make it show up on the screen and to move around. Those are the two big functions that we're going to need in the player. So I'm going to start by making a draw function. And in order to draw something in Pygame, there's a couple different ways. I'm going to start with just a basic rectangle, and maybe later we can turn it into an image, or if you want to make it a circle, you would do the same thing I'm about to do, but instead of rect, say ellipse. So I'm just going to say pygame.draw.rect, and the first argument to the rect function is where you draw it. So I'm just going to say screen. And then the next argument is the color the rectangle needs to be. So that's self.color. And then the last argument is a list containing the information about the rectangle in the order of what is the rectangle's X position. Well, this is just going to be self.x. Its Y position, its width, and its height, which is why I had to store all of that. Any questions about that? Has everyone been able to keep up and get this all typed in? Okay, cool. So after defining the player class, I'm going to go ahead and make the player. I'm going to say player equals player and give it all the arguments I want to give it. Let's say it's, it starts at 0, 0. It has a width and a height of 50 and a color. I'm actually going to go ahead and define my colors as constants up at the top. I guess right before I do this. So I'll go ahead and say blue is obviously 0, 0, 2, 55, and then yeah, that should be fine for right now. So I'm gonna go ahead and make the player. Actually, I'm gonna make them gold. What was gold? I've used this before. It's 255, like 215 0 or something like that. I don't know. It's gonna be whatever color this is. I'm calling it gold. I'll change the name later if I'm totally wrong on the numbers. Whoops. All right. So yeah, so I'm going to go ahead and say this player is gold. And now, in order to actually make it show up on the screen, I'm going to go back into my loop, and every frame I'm going to have to display it. So I can just say player.draw. And I also like to note for my students here that this is the drawing step, so that anytime they want to draw something, they know it starts here and ends here with this update. So now if I press play, okay, that's close enough to gold. Yeah, so there's my player. It's there at 0, 0 because Pygame's coordinates work just like HTML canvas coordinates, and some things you may have seen before, but maybe you haven't seen this before. It doesn't have the origin in the center. It starts in the upper left corner, which can be a little confusing at first, particularly if a kid is coming from scratch, where it does follow traditional Cartesian coordinates, because 0, 0 is the corner, and as the X coordinate gets larger, you get further right, which is expected. But as the Y coordinate gets larger, you end up going further down the screen. So 0 is the top and 500 is the bottom. and for left and right, 0 is the left and 500 is the right, like you'd expect. So it can be a little counterintuitive for a lot of kids, that when the Y gets bigger, you go down, but they get used to it. Any questions about that?
Oh, hey, Nick, Eddie in the chat is saying, yeah, we can only see your VS Code. Is it
Oh,
possible we
really? Oh,
could-
did I?
yeah.
I thought I shared my whole screen. Sorry about that. Let me find that. All right, technical difficulties. There we go. All right. Cool. So yeah, now we have that. Let's go ahead and continue. So yeah, let's go ahead and see this again. Which, oh yeah, that's another thing about Pygame. Since I have a window going already, and I press the play button, nothing happened. See, I press that, and it queues it up. So if I want to see a change that I made, then I need to close the previous Pygame instance, and then run it in the terminal, or like since I'm using VS Code, I just press the play button. But if I want to run it again, and like retype this into terminal, which is all VS Code does for me, it just runs it in the terminal again. If I sometimes kids are like, oh, why isn't it working? They press it several times like I just did, and then now every time I close it, it's going to come back up again, because each time it just queues it up. So yeah, does anyone have any questions about anything we've done so far? And does the coordinate system make sense here? Cool. All right. So now we actually need to get it moving. So how do we do that? So, I kind of got started. We're going to put something inside the player. So I'm going to go ahead and make a move function here. And I'm going to want it to move using the arrow keys, or using WASD, or really anything. But there's kind of two ways to get input in Pygame. Well, there's more than that, but as far as keys go, I can try to do it through an event here, which checks to see the moment they press it or let go, or just anything, anytime something changes with what they do. Or we can check the pressed library. So I can say, not the library, the dictionary of pressed keys. So I'm going to go ahead and get all the keys that are being pressed right this moment when this function is called, which is pygame.key.get pressed. And then, so this returns a dictionary with the keys as its keys, the keyboard keys as the dictionary keys. And the values of this dictionary are whether or not the key is currently being pressed. So I can say if pressed, and I'm going to go ahead and check the A key here. So pygame.k_A to get left. And I'm going to just have it also be the arrow keys, and you can choose one or the other to do, which would be k_left here. So if it's an actual letter you're putting in there, then it has to be lowercase. And if it's something else, like space or anything that isn't the letter itself, you have to type the word out in all caps. And that's how the constants work in Pygame. So if they're trying to go left, what am I going to do to make my player move left, keeping in mind what we already have in the player? Anybody know?
Y negative.
I'm going to move Y negative to move left, Jimmy.
Maybe.
What's that?
Maybe.
X
Maybe.
negative.
Yeah, we'll want to move the X negative. Yeah. So yeah, I'm going to go ahead and say self.x minus equals. I'm actually going to make a variable for this here. I'm going to say self.speed, and I'll just set it in here. Self.speed equals 5. So self.x minus equals self.speed. And I'm just going to do the same thing for moving right, but I'm going to change these values. So that's the D key, whoops, D or right, that are going to move me right. And so I just need to make this positive here. And now I'm going to be able to move either left or right. So go ahead and run this and test it out for yourself. Oh, yeah, whoops. Oh, did I make, oh yeah, I made a silly mistake. What did I do wrong? This is legitimately a mistake on my part. Why can't I move? Anybody know? I wrote this code in here for the move function. What's that?
You never called the move.
I never called it, right? I forgot to do that. So sometimes I do that on purpose when working with my students, but I didn't do it on purpose here. So I'm going to go ahead and make a whole new step here for the physics step as far as the organization goes. And I'm going to say player.move. And now if I run it, hopefully, yeah, I'm able to move. I shoot across the screen way too fast. Oh no, something's wrong. But I was able to move. My player was able to move left and right. Although it did cover the whole screen with that trail behind it. Does anybody know how to resolve that? Same way you would do it in P5.js or a lot of other drawing libraries. How do I make sure there's not a trail there when I go? I'm going to have to cover it. Oh, sorry, Chloe, if you were about to answer, but yeah, I basically need to cover over everything that happened in the last frame with what's going to happen in the new frame. Otherwise, it just stays there. The Pygame canvas works like a whiteboard where everything you put on top of everything else just covers other things. So the very first step of my drawing step is going to have to be to make a background. So I'm going to go ahead and say screen.fill blue. So now if I press play, there's a background here. And I don't have this trail now when I move, but I'm also moving really, really, really fast. Not a manageable amount for a platformer. And I mean, sure, I could make myself move less quickly. I can say like instead of 5, I'm going to go like 0.1. And yeah, this feels a little better for me, but it doesn't really solve the core issue of why I'm moving too fast, which is that Pygame's really just making it run as quickly as it can. It's doing, it's just running this loop as fast as it possibly can with no regard for any sort of consistent time, which means that if you have more sprites on screen or more calculations that you're doing in the loop, the game's going to slow down and it's going to speed up when you have less. And just because I have very little going on right now, it's super fast. But that's not just a problem with keeping it consistent on the computer, but it would be a problem with other computers, right? If I am running it on an old laptop versus a high-end PC, the game is going to play very differently because it's just going to be much, much faster on one and much, much slower on another. So in order to do that, I'm going to have to make it run at a consistent rate, which I can do using a handy feature that Pygame has. First, I'm going to write a constant for I'll put it here for how quickly I want the frame rate to occur. So I'm just going to say 60 frames per second. And I'm also going to initialize a Pygame clock, which I guess I'll just put right here. I like to put it, yeah, just for organization, I'll put right here. So clock equals Pygame dot time dot clock. So what this does, the clock is an instance of the clock class, as you can see, since it's capitalized, and has a bunch of useful functions, which I forget because I only ever use one, which is the tick function in order to limit the frame rate. So I'm going to make it so that it can't go above 60 frames per second. Now, obviously, I can't magically make it go faster if the computer, if we're just doing too many calculations and it's not able to hit 60 frames per second. This is just a cap. But as long as you keep your game, relatively simple and don't make any silly decisions as far as runtime goes, it should be able to pretty consistently hit that. So I'm going to go down into my loop, and I just have to put somewhere inside this loop, and I'm going to put it at the very bottom, but it doesn't matter at all where it goes. I'm going to say clock.tick, and then the frequency with which it should tick, FPS. So what the clock.tick function does is makes it wait until it has been long enough since the last time it was called that it is not going to exceed this frame rate. So this basically forces it to run no faster than the frames per second. So I'm going to go ahead and run it. And it's moving at a much more reasonable pace. I don't know how well you can tell over Zoom the difference in the speeds, but if you're running it on your own, it should be very, very different. Has everyone been able to keep up and get everything down that we've written so far, and it's working for them? It makes sense. You have the player moving back and forth. Okay, cool. So now our player is able to move back and forth, but that's not really that much of a platform, right? Platformers have to involve some vertical movement. Got to put in gravity and the ability to jump. Otherwise, what platforming is going to occur? So now it's time to add vertical movement, where I am going to be changing the Y value. So in order to keep a consistent momentum as far as gravity goes, I'm going to need to keep track of the velocity in the Y direction. So I'm just going to have a self.yv variable that I'm going to start out at 0. And inside the move function, you can make a separate function for this if you want to make a vertical move and a horizontal move. I personally like to just keep them together and just separate them by comments, but this is the horizontal movement. And then the vertical movement here is going to apply gravity. So first things first, I'm just going to change my Y position by the Y velocity. And in order to make gravity actually make the player speed up, I'm going to change it by 1 every frame. I'm going to say self.yv plus equals 1 and save it. And now I can go ahead and run that. And my player falls. Now I can't do anything about that. They're just going to keep on falling perpetually because I haven't added a way to change the Y velocity except for accelerating it downward. So there's just this bottomless pit for it. And funny thing actually, Pygame's drawing system actually loops around. So once it gets past a certain point in the bottom, it'll loop back around on top and then fall through again. Although I think it probably already has actually, but it just appears so quickly on screen for only 1 frame that we don't notice it. Does anyone have any questions about this? Okay, so now I'm going to go ahead and let's add the ability to jump. And I like to put this inside a function here. Def jump self. And in order to jump, all I have to do is set my Y velocity to some negative number. So this might be counterintuitive because you think of upward movement as being a positive value, but again, because changing the Y value by a negative number moves it upwards, that's what we want to do here. And you can change variable names or make it kind of work a different way where you can do like subtracting the Y velocity if you think that's more intuitive, and then making the Y velocity basically inverted, or make like this. Yeah, this should probably be a variable that's like gravitational force or something like that. Call it something like that to make it more intuitive. But anyways, yeah. So we set the YV to a negative number, which will make us rise up. So now we just need to figure out when do we want to call this function? When do we want to jump? And that's going to be when some key is pressed. W key, up arrow, space key. I'm going to make it the space key personally. And one way I could do that in theory is right here. You guys don't have to copy this down because I'm about to change it. But just to lay out something you could do. Well, if we press the space button, then we're going to jump. Does anybody know what the problem is with this? So I'm going to run this. I don't know how well you can see it, but basically when I hold the space key, I just float up. It's not really a jump button so much as a hover button, because this just like movement, this happens every frame. It checks, okay, if they press space, then I'm jumping and setting my y velocity to a negative value, which could be a fun thing if you're making like a helicopter sort of game or anything like that. But that's not what we're trying to do here. We're trying to make it a discrete jump so that when you press the space key once, you jump once. So we could do something like make a variable saying like, oh, space key held down, a Boolean saying that they've already pressed it so that it doesn't happen multiple times. But we can also just use Pygame system that checks that for us, which is to go back to our event system here, where we only want something to happen the one time it's pressed. And if they hold it down for more frames, that doesn't mean they get more jumps. So I'm going to go ahead and add another if statement. So I'll say if event.type is pygame.key down. Then I'll check to see what the key actually was. So if event.key is the space key, just like I added before. Then I'm going to go ahead and make the player jump. So if I run this now, I'm going to go ahead. Yeah, see, I run this now, and then I can jump all I want. So go ahead and test this out, everyone else, and see how it works for you. Go ahead and give me a thumbs up when you've tested it and got it working. Now let me know if there's any section of the code I should go to instead. Everyone got it? I saw 2 thumbs up. Okay, Jimmy's got it. Bobby got it. I'll take that as a yes. All right. So now let's go ahead and make it so that they can actually land on the ground for now. So because right now it just kind of ends, right? So I'm going to go ahead and have it land on the ground inside this vertical movement section. So how can I tell if it's on the ground? Unfortunately, there is no check edge function that I know of in Pygame. You're just going to have to check the coordinates manually. So one thing you could do is after you've made your movement and after you apply this change to the YV so that you can undo it if you find out that you're on the ground, you can check. You can say, all right, if self.y equals the height would be one thing you might think you'd be able to do. And I'm not too far off, just saying for those of you who already know Pygame and already know the answer to this, in case you're wondering why I'm doing it this way. We'll be changing in a second, but yeah, so if the Y position is the height, saying you're on the ground, then you'll just set your YV to 0. And that's pretty much it for now. I'm going to go ahead and press play and test it out. So if my Y position, okay, equals the height, I actually, then that didn't work for a couple reasons. This was actually a mistake that I made just now. Bad habit. That was a legitimate mistake. You need to make sure you check to see that it has become greater than it rather than equal to it, because if it doesn't perfectly align with the floor, then it's not going to register. So greater than or equal to rather than setting exact equality, because it just didn't happen to exactly hit the ground. If you're checking borders like this, you should always be using the the greater than or less than equals rather than checking exact equality. So I test this out and it still doesn't seem to work, but unless I made another mistake, it actually does work kind of. I stop and I haven't pressed anything for a while, but the moment I press space, it comes back. So it actually did stop at the bottom, unlike before, but it's stopping just under the bottom instead of stopping just above it like I want it to. And the reason for that is because Pygame always draws coordinates thinking of the top left-hand corner. So that is the player's coordinates. Its X and Y is its top left corner. So it will stop once the top left corner reaches the height, which isn't what I want. I want to consider not just its Y position, but one character height length below its Y position. So its Y position. So I would say self dot Y plus self dot height. If that is greater than the height of the screen, then I stop when I hit the floor. Although I end up kind of squished partway in, right? If I run it again, you can see that I hit the bottom here, and it takes me an extra jump to get out because I'm kind of stuck in it. And then, once I'm out, I can jump and move around. And then if I land again, I can still end up kind of stuck. Not always. Like in this case, I end up perfectly landing on it. So why is that? Why am I stuck in the ground sometimes? Anyone have any ideas?
Isn't it because you're going down by like a certain amount? So not always does it like perfectly align with the bottom.
Yeah,
So, like,
that's exactly
mechanical
right. It
path.
only checks this once per frame, and I'm going more than one step per frame, so it could end up skipping the bottom, which is exactly why it didn't work at all the first time when I had equals equals here, and which is why you end up kind of stuck inside. So what I can do if I want to actually stay on the ground is set this, once it detects that I'm on the ground, I just set the self.y to height minus self.height. So now, even though it lands, before it actually displays itself stuck in between, it moves it back up and puts it on the ground. And the order of these things does matter quite a bit oftentimes. I guess these two don't matter. But you do need to make sure you make this check after you've already made your motion for that frame, because if you do something like this, like putting this afterwards, and I hit the ground. Oops. Oh yeah, I didn't close my last one, so I'm having that problem. So I hit the ground, but then I can't jump because even though I'll make the jump and it'll set my YV, but then before it actually applies that velocity, it sees that I'm on the ground and sets it back to 0. So that's a common bug that happens. Same thing with if we put this self.yv plus 1 afterwards, like say I put this beforehand, but I put this afterwards. Then I hit the ground and then, oh, that actually was no problem. Never mind, that's fine. That didn't be good. I think actually, you probably can't see it, but I think it's like vibrating a tiny bit at the bottom because it gets set to 0 and then gets set to 1. Oh, so yeah, in this case, it's actually fine because it'll reset it before it applies the drawing. So I guess that's fine. But it can cause kind of some issues later on where it is actually applying that Y velocity each time. So Cool. Does anyone have any questions? Okay, so now the next step is to add the platforms. So just like with the player class, I'm going to make a platform class. So I'm going to go ahead and go up to, I guess, just right after the player. Do this up a little bit. Class platform. And the platform is going to need an initialization function, just like everything. You could just have like a bunch of rects, but I'll kind of tell you why I'm doing it this way. So I'm going to say self and then rect. It's going to take in a rectangle to apply itself. So rather than doing the X, Y, width, and height like we did for the player, we'll just have the rect kind of pre-built. So I'm just going to say self.rect equals rect. And then part of why we're making classes so we can make a draw function in here that'll display itself. And I suppose I can, yeah, put a color in here as well. So self, I'll keep it in the same order as we use it. Self color rect, say self.color equals color. So I'm going to do draw in the same way the player does. Pygame.draw.rect. And then first thing is where to draw it. That's the screen. Next thing is what color it should be, which is self.color. And then the rect that we want to draw it in. So that list of X, Y, width, and height, which is going to be self.rect. And if I actually want to make platforms, I can go ahead and make my platform list here. I can go ahead and say platforms equals, and then go ahead and define like platform. I'm going to make them all black. So I'm going to go back up here, make a constant for it. 0, 0, 0. And I'm going to go ahead and just start putting the platforms in. Which, so first thing first is it's going to be black. And its coordinates are going to be something like height minus 50. And then I'll also just say like 50. So it'll start a little bit further to the right. 100. And then width and height, I'm just going to go ahead. I'm just kind of picking numbers here. They're not too important. 220 is what I'm going to do there. Yeah, that should be fine. And now that I have that, and I can make as many of these as I want, but hopefully if we have time, I'm going to show you a better way to do it. But this is fine for now, so we can actually build up the platform. And so now I just need to go through them all and draw them. So I'm going to go back down into the drawing step. And then the order here is whether you want whether it goes before or after you draw the player is whether you want it to be above or below the player on screen. And I am going to put them below the player so they will cover the player if the player ends up behind them. It doesn't really matter because at least for this, what we're doing, because in theory, the player should never get behind the platform, should never overlap, but it is something you should think about with each one. So I'm going to say for platform in platforms, platform.draw. All right, so I drew it over here. So did I end up? Oh yeah, whoops. What was I thinking there? I mixed up the X and Y. I don't know how I did that, but 100 and then height minus 50. I need to make sure I close this before I press the play. Yeah, so I end up with the platform there. And you can see that because I drew it after the player, it covers the player. But it doesn't actually do any platform stuff. Which we want it to, right? We want the player to stay on top of it. So in the interest of time, I'm going to have the player check to see if it is colliding with any of those platforms. So I'm going to go into the players. Yeah, I'm going to go into the player, and I'm going to give the player a hitbox. So inside the player, I'm going to say self.rect. And it's going to be a rect object, which I guess I could create here, but I'm going to do it actually a slightly different way. I'm gonna need to constantly update the player's hitbox, with the draw function actually gives for us. When it draws a rectangle, it returns that rect as an object, and rects can be used as a hitbox. So I'm going to say self.rect equals pygame.draw.rect. And then I am going to need to make sure that it has this in the beginning, just because I want to perform the physics step before the drawing step. And if I try to check for collisions before the first time I've drawn it, it won't have a rect and I'll crash. So I'm just going to say self.draw in here in the initialization function, just to make sure it actually gets that rect object created. Does anybody have any questions about that? And then if I'm going to have a hitbox for the player, I'm going to need hitboxes for the platforms too. So, oh, you know what? But yeah, I forgot that I changed this hitbox. So let's keep it consistent. Let's call this the hitbox, self.hitbox, because the rectangle already has something called self.rect, and I don't want to make it confusing. So platform is going to say self.hitbox equals, and so is player. So self.draw in order to give them each a hitbox. So I'm just going to go ahead and run this real fast just to check that I didn't make anything crash. Okay, nothing crashed, so that's good. So each one is going to have a hitbox in the draw function, so that will update with draw every time. So now let's go ahead and get going on actually using these hitboxes to make it so that you can land on top of the platform. So we can put this inside either the players or the platforms, but I think it makes a lot more sense to me to put it inside the player. We're going to have a check collide function that will check to see if it is colliding with any platform. So I'm going to define check collide self and platforms. And now I'm going to go ahead and go through every platform to see if it collides with that rectangle. So I'm going to say for platform in platforms, if self.rect.collide platform.rect. And it doesn't matter which one you do. This is just a function inside the rect object in Pygame. Sorry, it should be hitboxes. Hitbox. Self.hitbox and platform.hitbox. So this is a function within the rect object of Pygame that takes in another rect and sees that they're colliding. So it doesn't matter which one you do, because either way they're going to be colliding with each other. So if it's colliding with that platform, then I'm just going to go ahead and return that platform in case we're going to need that platform later for anything, which we would if we had time. But that's one of the things about the platform and why I wanted to show it. Maybe I underestimated it a little bit, but you can make it relatively simple, or you can get really advanced with it, with how much you want to add into it. So it's good to make these flexible things where it's like, okay, rather than just saying true or false, I'm going to return either the platform or none in order to customize it if we want to do anything like reacting to that specific platform. So now for this vertical movement, I'm going to say, like, if this happens, then I'm going to move it here. But then if I collide with a platform, yeah, if check collide, well, self.check collide, sorry, self.check collide. And then I'm just going to use the global platforms list. Then I'm just going to go ahead. Wait, is there no? Oh, it's not defined. Yeah, okay. Yeah, by the time it's called, it'll be defined. That's why my linter's upset. But if I collide with the platforms, then I'm just going to set the YV to 0. To make it stop doing that. So now I'm going to go ahead and run it and see what happens. Okay, it crashed. What did I do wrong? Pygame.rect object has no. Oh, it's collide rect. Sorry about that. Is that how you do it? Okay, yeah, there we go. It's not collide, it's collide rect. So on line, for me, it's 52 inside the check collide function. It needs to be collide rect to see if it's colliding with that rect. So now if I jump on it, it's going to set the speed to 0, but it gets a little weird. So we'll want it to react in the same way as the bottom, where if it's colliding with it, then we'll want to move to the top. So maybe it would be better to say, so if it's colliding with it, then I suppose we don't actually need. Yeah. So yeah, this part's fine. It would be up here. So if we'll go ahead and set a variable here. We'll say platform equals self.check collide platforms, and then if platform, then we'll set the y to 0 and move it up. So I'll say self.y equals platform.y minus self.height. Okay, didn't like that. All right, platform.rect.y. Right. Since these lists are what I'm using here, it would be bracket 1. So maybe we should have used because since we didn't get to y, I'm using the rect. But yeah, so here it works a little weird again, where you can just kind of jump onto it. And the way to solve that is by having different hitboxes on each part and seeing which part touched it and knowing whether you're hitting it from the side, whether you're hitting it from the top, and so on. So basically, you can make this platform detection system as simple or as complex as you'd like. But I think this gets the job done decently well right here, as long as we make sure that, yeah, we teleport to the top, and that is all good. Although something's up with my ordering here. Oh. Does anyone have any questions about that? Is that working for them? Okay, cool. So one last thing, we didn't get to it, unfortunately, and you guys can ask me about it or look into it yourself if you know how to load JSON in Python. I made this creator.py file, which I'll send to you guys, which actually the whole point of it is to make levels in Pygame so that you don't have to just grind out the code. So you can basically just make like platforms like this, and then it'll save it in a JSON file that you can load in to make the level, so you don't have to make just a long list like this. So let me go ahead and send that to you. And if you want, like I said, if you want help with that, like how do you use this, how do you interpret it, how do you like incorporate it into a platformer game, then please let me know, because I find that, I don't want my students to have to guess and check these numbers here to see if the platforms are where they want them to be. So I made this little script here, which I will send to you guys now. Oops. Which I also made. I think I'm going to update it because I made it a couple of years ago, and looking through it, I'm kind of embarrassed by how some of it is coded. So don't look at the code, just run it and just trust me on it. Yeah, it basically puts the platforms into a JSON file, which then can be loaded up so that kids don't have to guess and check their platforms. They can just build it real fast and then put it into their level. So what it does is it saves the platforms in a level1.txt file that you can then load up and transform into these platforms, which is why I wanted it to be a rect object. But anyways, does anyone have any questions about Pygame in general? Cool. So there's a lot of projects you can do with it. A platformer, like I said, is a great one, and I think that since we all are relatively experienced coders, we could show it and kind of see how it can all come together and be customized. But usually when starting out, I like to do a more simple, just kind of like bouncing ball sort of project where you create a whole bunch of them. And I actually like to use it as a way to introduce classes in general. Like we make one bouncing ball, and then like, well, what if you wanted to make 100 bouncing balls? Would you have to have a variable for every single one? No, you create a class and then create 100 of them with a loop, and that can be kind of a neat visual exercise. But when they want to make real games, quote unquote, that's where the platformer can come into play. So yeah, thank you all for being here. Again, if you have any questions or want to expand on this, since we didn't quite get to finish everything I want to talk about, but I think it was a good enough level that I think we can finish up here, then please don't hesitate to reach out. And yeah, thank you. Bye, everyone.
Also, I think that access to the drive is not accessible.
I could have sworn I shared that a while ago. Maybe it's changed since then. Or you know what? Yeah, I think so. I did. Wait, no, it says anyone can view. Maybe I copied. Maybe I pasted the wrong link in. Let me share that. Thank you for checking that, Eddie. Try that now, because oh yeah, that is a different link. I wonder what I copied. What is this? Oh, I think I copied the whole folder. Yeah, that's what I did. So that's just in the Coder School Google Drive anyways. If you look in my folder, then yeah, you can, then it's there under creator.py, but easier if you get that link. All right, cool. Bye, everyone.